So today I will go through the encoder, which is one of the 3 transformer architectures. In this video I will go through tasks the encoder specializes at. I will show you a quick example of how the encoder solves a task, and I will talk about the process of pre-training an encoder and how you can then use this pre-trained encoder to fine-tune towards a specific task. I will introduce some of the math in the encoder, and finally I'll talk about some pros and cons of the encoder. So the encoder specializes at bidirectional context understanding, and what that means is that the encoder reads sentences from left to right and right to left to get a great understanding of the connections between the words in the sentence. So tasks the model specialize at are next sentence prediction, where the model has to decide whether or not a sentence is followed by a previous sentence. Another example is mask LM, where some tokens in the sentence is masked out, and then the encoder has to predict the correct tokens to replace the masked token. Another example is question and answering, where the model has to find an answer in some paragraph that answers the question. And finally, sentiment analysis, where the model, based on a sentence, has to predict either positive, negative, or neutral based on the sentiment in the sentence. So that could be, for example, to analyze movie reviews. Okay, let's just quickly look at the layout of the encoder. So the encoder consists of a multi-head attention layer, and that is what reads the sentences from left to right and right to left. Then it goes into a feed-forward neural network, and finally into a task-specific output layer. The encoder always needs a task-specific output layer. What that means is that the encoder always has to be fine-tuned towards solving specific tasks. But you don't start off by just fine-tuning towards a specific task. You start off by pre-training to give the model some general understanding of language and how to use this bidirectional context understanding. So let's dive into pre-training. In this video, I'll go through how the BERT encoder is pre-trained. And why use BERT? Because BERT is one of the most famous encoders, and it still performs very well today. The BERT is pre-trained using 2 tasks: next sentence prediction and masked LM. So the layout of the BERT is that it takes as input 2 sentences separated by a separator token. And then in the task-specific output layer, we have this NSP neuron. And this neuron is binary, so it's either 0 or 1, based on whether or not the sentence follows the previous sentence. The rest of the task-specific output layer has to do with the masked LM task, because this is where the model returns the correct sentences with the masked tokens replaced with the correct tokens, if the model performs well. So what we do is that we have a huge data set of next sentence prediction samples, and 50% of the time the sentences actually do follow the previous sentence, and 50% of the time the sentence doesn't follow the previous sentence. The other task, masked LM, 15% of the time the sentences has masked tokens, and 80% of the time you use the mask token to replace the word, and 10% of the time you replace the word with another random word, and the last 10% you do nothing with the token. And why not use the mask token every time? Well, that is because in a production environment, a user would not use this mask token. In a production environment, the user might put in a sentence with misspelled words or words that doesn't fit in the sentence, and then the model will have to be able to replace those words. And it cannot do that if it has not been trained to do that with these random words 10% of the time. So when you pre-train, you combine these 2 tasks, so you essentially have masked next sentence prediction. Moving on to fine-tuning. When you have pre-trained the model, the next step is fine-tuning. Unless the task you wanted to solve is next sentence prediction, then it's already been pre-trained to do that. But for example, question and answering. Here we've swapped out the output layer with a question and answering task-specific output layer that just takes 2 indexes, the beginning and end token of the span that answers the question. So let's just see how that works with an example. The input is the question followed by a paragraph that contains the answer. Then the model reads the sentence from left to right and right to left, and then it spits out the start of answer token and end of answer token, or just the index of the start and end. So how it works is that the model gives probabilities to every single token based on whether or not this token is likely to be the beginning of answer token, and then it does the same thing but for end of answer token, and then you can get the paragraph that contains the answer. So now it's time to go through some of the math in the encoder, and I've actually already done that in a separate video. So I highly recommend you go watch that so that you'll get a very deep understanding of how the math works in both the encoder and the decoder and the encoder decoder. So the final thing I want to talk about in this video is the pros and the cons of the encoder. Now the encoder generates deep bidirectional context understanding of every single token in the input. And this can be used to be fine-tuned for downstream tasks like question and answering. And the BERT-based models are still highly competitive even today, especially in text classification and question and answering. Here they still rank very high compared with the state of the art. Now some cons of the encoder is that you have to fine-tune towards every single task. This is a difference from the decoder that doesn't have to be fine-tuned, as you can use prompts and then the decoder will just predict the answer. A huge difference from the encoder and the decoder is that the encoder, for example with question and answering, it doesn't actually know the answers. The knowledge is not stored in the weights, because you have to supply it with the paragraph that contains the answer. Then it can sort of look at the question and look at the paragraph, use bidirectional context understanding, and then, all right, so this is probably the answer to the question. Whereas with the decoder, you just ask it a question and then it's able to actually predict the answer to this question. So the decoder actually knows the answer where the encoder has to find the answer. So I hope you enjoyed the video and you now have a much better understanding of the encoder. If you have any questions, feel free to leave them in the comment section below, and I hope to see you in my next video.